Greetings, fellow knowledge seekers. Welcome to PaperLedge, where we transform groundbreaking academic research into bite-sized brilliance. I'm Ernis, your guide on this journey of discovery. Today, we are diving deep into a fascinating paper titled Zhyper, Factorized Hypernetworks for Conditioned LLM Fine-Tuning. It's a mouthful, I know, but trust me, the concepts are pure gold. So, what's this paper all about? In a nutshell, it tackles the challenge of making large language models, or LLMs, behave in specific ways, like adopting the tone of a particular culture or adhering to a specific viewpoint. Ever tried to get an AI to write like Shakespeare? Or perhaps channel the wisdom of a Buddhist monk? It's trickier than you might think. The core issue is that LLMs are pre-trained on massive datasets that have their own inherent biases. Imagine trying to repaint a masterpiece that's already hanging in a gallery. It's not easy to overwrite those ingrained patterns. Now, previous attempts at fine-tuning these models often involved directly tweaking their weights, which, surprise, introduced a gazillion new parameters. It's like trying to fix a leaky faucet by building an entirely new plumbing system. That's where the ingenious Zhyper framework comes in. Think of Zhyper as a master puppeteer, skillfully guiding the LLM with minimal interference. The key innovation, it uses something called a Factorized Hypernetwork to generate context-aware LORA adapters from textual descriptions. Still with me? Let's build our memory palace. To break this down, first, picture a grand, old library. Each room holds a different piece of this puzzle. Room 1. Contextual information. This is where the magic begins. The authors use a transformer-based encoder, pre-trained on a ton of text, to turn descriptions of cultures or values into fixed-length embedding vectors. These vectors are like the DNA of a specific context, feeding directly into our model. Room 2. Factorized Hypernetworks. This is where the real wizardry happens. Abracadabra. The hypernetwork takes the contextual DNA from Room 1 and uses it to create context-aware LORA adapters. These adapters are like tiny, specialized lenses that subtly reshape the LLM's perspective. Room 3. LoRa adapters. These are the unsung heroes of this story. LORA, or low-rank adaptation, is a parameter-efficient fine-tuning technique. It essentially freezes most of the LLM's original weights and only trains small, low-rank matrices. Think of it as adding a few brushstrokes to a painting rather than repainting the whole thing. Now, the beauty of Zhyper is that it doesn't generate all the parameters of the LORA adapter directly. Instead, it creates a compact, contextual modulation signal. It's like a subtle nudge that guides the adapter in the right direction. Room 4. The grand finale. Fine-tuning. Finally, we integrate these hypernetwork-generated LORA adapters into the base model. The goal? To minimize the supervised fine-tuning loss over datasets and their associated contextual descriptors. It's like teaching the LLM to dance to a new tune without forgetting its original rhythm. But does it actually work? Well, the results are quite impressive. Experiments on multiple benchmarks show that Zhyper achieves competitive performance with up to 26 times fewer parameters than state-of-the-art baselines. The team even extended Zhyper to cultural alignment, demonstrating improved generalization to out-of-domain settings and a better capturing of fine-grained contextual values. Imagine training an LLM on European literature and then having it effortlessly understand the nuances of Japanese haikus. That's the power of Zhyper. Now, you might be wondering, why does this matter? Well, consider the implications for creating AI systems that are more sensitive to cultural differences, ethical considerations, and specific task requirements. It opens up a world of possibilities for personalized AI assistance, culturally relevant content generation, and more. So, what's the takeaway from all of this? Zhyper offers a parameter-efficient way to condition LLMs, enabling them to adapt to specific contexts and tasks with remarkable finesse. By using factorized hypernetworks and context-aware LORA adapters, Zhyper achieves competitive performance with significantly fewer parameters. As we continue to explore the vast landscape of AI, frameworks like Zhyper will be crucial in shaping LLMs that are not only powerful but also adaptable, ethical, and truly aligned with human values. So keep exploring, keep questioning, and never stop marveling at the wonders of the cosmos and the mind. Thanks for joining me on this episode of PaperLedge. Until next time, keep those neurons firing. And remember, the universe is vast, but our capacity to understand it is even greater.